Welcome everyone. Today we are going to discuss a question in the chapter of kinetic theory of gases. The question is regarding uh, Regnault's experiment. So, in this question, we have a gas. That gas is kept in isothermal conditions. Isothermal conditions mean if some part of the gas is taken out from the enclosure in which the gas is there, then the temperature of the gas will not change. So, what happens in such a case? When we take the gas out of uh, its container, so in this case, we have a gas whose volume is 40 centimeter cube. So, and its initial pressure is some 600 pascals. Kilopascal volume. Meter cube. Then we have the final pressure of the gas. Uh, so this is the temperature at which the gas is maintained. So what happens is that we have taken out the gas and the gas is now flowing through some calorimeter. This raises the temperature of the calorimeter from 20 degrees Celsius to 30 degrees Celsius. The calorimeter uh, is described as having some water equivalent, uh, which means that if we supply some 1 joule of heat to that calorimeter, then it would be same as supplying that 1 joule of heat to water. So if we know the water equivalent, which is 100 gram, we can find what is the heat given to the calorimeter. So this is provided by the gas which we have taken out from the enclosure. So the question is, if uh, this whole thing is given to us, what is the molar specific heat of gas at constant pressure? So we say that when the gas is taken out, it is taken out at a temperature of 100 degrees Celsius. So it is taken out initially at 300 Kelvin. Eventually, final temperature of the gas after it is taken out, we heat it to some 100 degrees Celsius. Now what happens is that this heated gas is passed through the calorimeter. So after passing through the calorimeter, what happens is that the gas is giving heat to the calorimeter. So initially the heat exchange would have happened at 20 degrees Celsius, and finally the heat exchange would have happened at 30 degrees Celsius. That is, the calorimeter is slowly gaining heat. So what can we say uh, about the eventual temperature of the gas? That is, in the end, what is the temperature of the gas? Its value would be the average of 20 degrees Celsius and 30. So it would be some 20 plus 30 by 2. So that is 25 degrees Celsius. It's a pretty big question. Uh, Even describing this question takes at least 5 minutes. So we want that. What is the process through which uh, we go through to find our molar specific heat? And first of all, we will say the equation which we use is PV upon RT. So initially the gas was at some P1 pressure, right? So its moles was N1. That is how the gas was initially. Eventually, the gas was at, so this was the mole of the gas. If we change the pressure, the moles of the gas have changed, delta N. So this amount of gas we have taken out. This would be this T will be the initial temperature, right? This would be the initial temperature. R would be the universal gas constant. So now this moles of the gas, that is delta N, that we have to use to uh, heat our calorimeter. We'll say what is the heat which the calorimeter absorbed. So that would be the mechanical equivalent of, or what we say water equivalent of the calorimeter into 4.2 joule per gram per degree Celsius rise in temperature of the calorimeter into change in temperature of the calorimeter equal to Q. This is the heat provided. This would be some 4200 joules. Now we'll say this heat is provided by the gas, which is this delta N moles we have taken out. We'll say delta N into Cp into change in temperature of the gas is equal to 4200 joules. Step Cp equal to 4200 divided. So this the temperature of the gas which has changed. So how has the temperature of the gas which we have taken out changed? We first heated that gas to 100 degrees Celsius. Then it uh, came to the average temperature of the calorimeter. I hope that part is clear. After calculating this whole thing, you will get the answer. But I want to summarize the whole thing. Uh, we say that there is a gas uh, maintained at some certain temperature. Now, we say that that gas has been taken out uh, and then it is heated. The purpose is that we want to find the molar specific heat of gas. So that depends upon how the gas is supplying heat or taking heat. Okay, so then it is, then we say that gas is passed. It changes the temperature of the calorimeter. Uh, the gas's temperature also changes, and we have already figured out what is the change in moles of the gas. So this change in moles is basically what is amount of gas we have taken out. So whatever gas we have taken out, that only is supplying the heat to us. So that delta N we have substituted here. That is the big expression you might be seeing. P1 minus P2 into V upon RT1. This Ti is the initial temperature, which is 300 kelvins. So remember that this is 300 Kelvin, R is 8.3, volume is some 4 into 10 to the power minus 2. So if you cube it, it will be some 64 into 10 to the power minus 6 into the change in pressure, which is 25 kilopascals or 75 kilopascals. That would be 75 into 10 to the power 3. After calculating the whole thing, you'll get the answer. It would be some 20 joule. So what could this be used for? This could be used for finding the type of the gas it is. We can use it to find whether it's a monatomic gas or whether it's a diatomic gas. And since the temperatures are lower, there are no vibrational frequencies in. So this is one of the methods called Regnault's method.